Hello students, welcome back to my channel. In this video, we will be doing chapter 7 from your NCERT class 12th computer science book, and the name of the chapter is Understanding Data. So let's first understand what do we mean by data. So one thing should be very clear in your mind, that data is not equal to information. Okay, so data and information are not the same. So what is data? Data is just a collection of values, okay, and those values can be of any form. They can either be numeric values, that means they can be numbers, they can be characters. The values can be present in the form of characters or even in the form of symbols. And when you derive some useful patterns from the data, when you study the data, analyze the data, then at that point you derive information from data. Okay, so this is how data and information is different, and you should stop using these terms interchangeably if you have used them in the past. Okay, so now coming to some examples of data that we see in our daily lives. Census data is an important kind of data that is collected by the government to know the population, to know the size of population, the gender, the ratio, and so on. So another kind of data that you see almost every day and multiple times in a day is the data which is present in the form of images and videos, that is present on online social networking sites or any kind of platforms on your websites. Okay, textual data, images, videos, any kind of multimedia. Then any banking task or transactions that you do lead to the collection of banking data. Similarly, the patient data is collected by hospitals or clinics and doctors, which is referred to as medical data. Then we have placement data, shopping data, satellite data, and so on. There can be many examples. These are very few of them. So before I proceed further, I like to mention that the word data is in itself the plural form and the singular form is datum. So for all those who did not know this, I hope in future you use them correctly. So now we must know that why data is important. Data is important because, as I mentioned, when we have a large amount of data, we can uncover useful patterns from that data, and that patterns can help us derive some useful information. And when we have information, we can take some important decisions based on the data. For example, if customers are buying two kinds of products almost every time together, then this data can be used, this information rather, after the data has been analyzed, this information has been derived, and this information can be used to place both those products side by side in a shopping center, so that the customers have easier access to both these products and their sales also go up. So basically, such decisions are based on the information that is that is derived from the data that is collected from different sources. Now, in recent times, the amount of data that is generated by digital devices has increased, and the speed of the data has also increased because there are so many devices, and the speed of internet has also improved as compared to the past decades. Therefore, we are being gifted with a large amount of data that can be utilized to derive lots of information. And since manual processing or manual analysis, that means humans cannot process such large amounts of data as fast as a computer can do so. That is why computers are utilized now to collect, to store, to process and analyze the values that are being collected, the data that we are gathering. Okay, And using computers, we derive information and we take important decisions when we have processed the data and analyzed it. We have derived some useful information from it. And this is generally done using data summarization and visualization techniques. So since a lot of numbers can be very boring and can be very confusing to look at, so generally people who work at analyzing data, or people who analyze data to derive some useful information, they summarize or they create a summary of the data by creating charts, by creating some visual diagrams which are easier to understand and quicker to interpret. Okay, so this is what we are going to learn in this chapter, that how can you make use of the data that is available to you, how can you collect it, how can you store it, and how it can be processed to derive useful information. Now, one very commonly seen example of important decisions or being taken based on data is the cab prices, the surge in cab prices that you see. So you might have noticed that since in near future, in recent past, whenever you start booking your cab, you see a surge in prices whenever there are peak hours. So sometimes you get a message that at present fares are higher due to increased demand. So what is actually happening? The company is collecting the data about how many users are requesting the cab at that moment, and it also has the data of how many cabs are available at that particular location. So it is using both these informations which it has derived from the data it has to take a important decision of increasing the prices, because obviously if users want cabs, they will be willing to pay a little higher as compared to taking the decision of not taking a cab, right? Similarly, the data of customers that visit visit different kind of restaurant is analyzed and used by those shopping centers to find out what is the appropriate time when the shops can offer, when the restaurant can offer the discount, and those are generally the times when the footfall is usually less. Because if a restaurant is offering heavy discounts during peak hours, it will not make as much profit. But it is, if it is offering discounts at a time when the footfall is less, when people tend to be less in visit, tend to come in less, then that can lead to an increase in sales and will also give out a good image of the restaurant. Similarly, the data about vaccines, the effectiveness of vaccines or the side effects of vaccines are important information. This is another kind of information that is derived from the patient data that is collected. And another example is the search engine optimization techniques, which give you results. Whenever you search something in a search engine, the results are displayed in a manner based on what query is more suitable to you. So all that analysis is done at the back end, and a lot of processing is done so that you get these results. Okay, now before moving to data collection, storage and processing, I would like to explain very quickly about the types of data. So since we have different sources from which the data is generated, from which the data can be collected, that is why there are different formats in which the data can be present. Okay, so the two main types of data are structured data and unstructured data. Let's first understand what is structured data. Structured data basically is any kind of data that follows a fixed format every time. It is very well organized and it is recorded in the same manner, and that manner is in the form of a table. So structured data refers to any kind of data that is stored in a tabular form. That means in the form of rows and columns, and each row represents one observation in that data, and every column represents an attribute or a property of that observation. So for example, if we have an attendance register that is also generally present in the form of rows and columns, that is a tabular data. So every entry, every row will be the name of a student, and the column will represent the attendance of the student. So it is a property of that row. That means an attribute or a feature of that particular observation. Okay. So this is the structured data, and one important thing that you need to remember about structured data is that its format will always be the same as compared to unstructured data. In case of unstructured data, there is no fixed pattern in which the data will be displayed. So the biggest and easiest example of unstructured data should be the news that you see on a newspaper or the websites or emails. See, you get newspapers every day, right? You get information in newspaper every day, but there is no fixed format of the content of the newspaper, right? So sometimes the first page may have a very big picture at the very center, or the other day it may have a bigger headline and a smaller picture. Sometimes the columns might be, some spaces might be left empty because there is no content fitting that space, or sometimes some columns are divided among different pages. So the main structure, the heading, the name of the paper, the page, date, these are fixed, but still the internal content of the newspaper is not fixed. Similarly, while writing emails, there is no fixed format about the content. You can write multiple points, you can number the points, you can write multiple paragraphs. There is no fixed content, but it is data. You can derive information about you can derive useful information from a collection of emails also. What kind of language is most popular while writing emails? What is the most popular structure, or anything, right? Similar thing holds for website. Different kinds of websites follow different kinds of structures. There is no fixed format, and all this comes under unstructured data, right? Now, unstructured data is mainly described using metadata. So in the case of structured data, we saw that every observation or every row has its properties written in the form of columns. But in the case of unstructured data, the unstructured data is described using metadata. Now metadata means the data about data. So for example, if we have an image is in itself a kind of data, right? Now when we use or when we provide information about this image, like what is the type of the image, what is the resolution, what is the size of the image, all these fields, all these properties are some data about this image data. So these values, these properties are referred to as metadata in case of unstructured type of data. Okay. Similarly, for an email, apart from the content, what are the metadata that describes the main data email? So when I say email, I'm mainly referring to the content of the email, and metadata is anything, any data that gives more information about the main part of the data, right? So what more information we are getting about the email? We are getting more information about the sender, the receiver, the subjects, and so on from the metadata of email, which is the subject, the attachment, the receiver, sender, and so on, right? So now after understanding what are the two types of data, let's come to the first step of understanding data, which is data collection. So every time you want to derive some useful information and take a decision based on some kind of data, you'll first have to collect data, right? Data collection is basically the process of identifying the sources from which you can collect your data, the data that you want to collect. You first need to identify the places from where you will get the desired data, and that gathering of data is basically referred to as data collection. Okay, so you first need to collect the data that you want to analyze. Now, how the data is collected? See, one example is that whenever you have elections, and on the day of the elections, exit poll data is collected by setting up booths outside or just outside the premises of the polling booths, where people are asked to tell for evaluation purposes or for surveying purposes that whom did they vote for. Okay, so this is the exit poll data which is gathered from the voters themselves when they exit out of the polling booth. Similarly, patient data is gathered by maintaining records of the diseases that different patients came up with, what medication they were prescribed, how many days they stayed into. So patient data, or the data that is gathered by hospitals, is gathered from the patients. That patients are the source of that data. Okay. Similarly, customers and the frequently bought items by the customer become a source of the data that are collected by shopping centers, right? Now, after you have collected data, you'll have to store this data. And how do you store this data? You store the data using different storage devices. And why do you need to store data? Data storage is important so that the data can be used and accessed and manipulated in future also. So sometimes you know that this information and this data will never be used in future, so you can discard it. But when you know that this information will be very useful and might come to my use in future as well, then you need to save that data securely, and you need to store the data in storage devices so that you can retrieve and utilize that data for later use, right? Now, in storage devices, data is stored in the form of files, or it can also be stored in the form of databases, right? Databases are again a collection of data, generally in tabular form, and files do not have a fixed format. So if you talk about text files, text file will contain textual data, but it does not specify how many paragraphs, how many bullet points it will have. Similarly, coding files, Python code files, are also a source of data with no fixed format. Okay, but one thing that you need to remember is data is stored in storage devices, and some commonly known and used storage devices are hard disk drive, solid state drive, which you also refer to as SSD. Then you have pen drives or USBs, memory cards, SD cards, and so on. Now, after you have collected data, you have stored data somewhere, now you need to process that data so that you can find something useful out of all those collection of values that you have stored and saved in your device. Now, the information that is derived from this data is then used to make useful decisions. And to come to these decisions, different statistical techniques are used so that this large amount of data can be summarized. Okay, so data summarization is one part of data processing. So basically, processing means you are working with the data, you are changing it in a way so that it becomes more understandable, easily interpretable, and so on. So you are creating a summary so that whatever is present in that data can be understood, but it will be easier to understand. Okay, so statistical techniques are used for this purpose, and two most important statistical techniques are: first is measures of central tendency, which include mean, median, and mode. And second is measures of variability, which include range and standard deviation. So in the topic of data processing, you only need to study statistical techniques that are used for summarizing the data, And there are two main kinds of statistical techniques. The first is measures of central tendency and the second is measures of variability. So let's understand both these one by one. Starting with measures of central tendency. So these are the values, or these techniques give an insight or give some information about the data, or they give an idea about the data through a single or a few values. So I'll explain this in more detail one by one as we see all the three techniques: mean, median and mode. So what is mean? Mean is the first type and the most important type of central measure of central tendency, and mean in common terms is the average of all the numeric values that are present in an attribute. So from this point you need to take care of three things. Firstly, that mean is the average. Okay, it is the sum of all the values divided by the number of values. Secondly, mean is calculated only for numeric data. You cannot calculate the sum of textual data, right? So mean is applicable only for numeric data, and if you're finding the mean, you will be finding it for each attribute separately, right? So what is the formula for mean? Sum of all the numeric values that are present in that attribute for which you are finding the mean, divided by all the number of values. That means the total number of values that are present in that attribute for which the mean is being calculated. Now, mean, since it utilizes all the values that are present in an attribute, it is not suitable when your data has outliers. Now, what is an outlier? An outlier means something that does not follow the general pattern of data. So for example, if in an attribute most or almost all the values except a single value lies in the range of 50 to 100 and one single value is 4000, then that value is an outlier. Or on the other side, if one value is say 4 and all the other values lie in the range of 1000 to 4000, then that small value 4 is an outlier. It is lying outside of the normal range where the majority is lying, right? So outliers are either very large or very small values as compared to all the other values in the data. And outliers are generally considered erroneous or considered as errors, because if outliers are considered while calculating the mean, they will drastically change the resulting value. Okay, so if a very large value is added into the mean, the sum will change. That means the numerator, the sum of all the values, will change, the denominator will also change, and the result will be very different to the case if the outlier would have been removed. Okay, so the mean is not very suitable in the case when the data has outliers. So either you can use some other measure or you can remove outliers in this case. Okay, so the better way is, when you have to use the mean, you remove the outliers before calculating the mean, right? Now let's take an example. So this is the formula for calculating the mean. If there are n number of values and if each of these values are say x1, x2, x3 and so on till xn, then the mean will be given by sum of all these n values divided by n. So if we have a question that says that these are the heights of students that are present in a class and we want to find the mean. So first we'll have to find the sum of all these heights and then we will divide it by the total number of heights that are present, which is 9 in this case. So the value would be the sum, which is 912, divided by the total number of observations, which is 9. So 912 divided by 9 will give you 101.33 centimeters. This is the mean. This is the average value. So mean is generally the representative value. That means if you want to summarize your data using a single value, then that is the mean. Mean reflects that all the other values are present very close to this value, either very close in the negative direction, that means closer in lesser values, but they are lying close to this value 101, like the value 90 here, like the value 85 here. So these are the values that are close to 101, and there are certain values that are higher than 101 also lying on the other side, like 110. But again, the mean is a representative value. It balances and it represents all the values present in that attribute. Okay. Now next comes the median. Now what is the median? As the name suggests, median is that particular value which divides the data into equal halves. It is kind of the middle value when the values in the attribute are present in a sorted order. Now this sorted order can either be an ascending order or it can be a descending order. So basically, whenever you have to calculate the median, the first step that you have to do is to arrange the values of the attribute for which you are calculating the median. Arrange those values in either an increasing order or in a decreasing order, and then you find out what is the middle value. Okay. Now, median is also computed on for each attribute separately, and if there are odd number of values, then there will be a single middle value, such that the number of values on the right and the left of the middle value will be the same, and there will be a single median. But if there are even number of values that are present in an attribute, then there will be two middle values, right? So the median will be calculated by taking the average of those two middle values. Okay. So the median divides the sorted list into two equal parts, and that is why we call it the middle value, right? So if this is the data for which you want to find the median, this was the height of the students in the previous question, the first step would be to arrange this data in ascending order. You can also arrange it in descending order. I'm arranging it in ascending order, right? Now, once I have arranged or sorted this data, I'll now check what is the middle value. So 4 observations this side, 4 observations this side. Since there are odd number of values, there are a total of 9 values. So I will have one middle value, that is one median, and that is 102 centimeter in this case. All right. Okay, coming to mode. Now mode means the value which is occurring the maximum number of times, or the value that is the most frequent in a particular attribute. Okay, so the frequency of occurrence has to be calculated to find out the mode. Okay, so again, mode is calculated for each attribute of the structured data, and for each attribute for whom you want to find the mode, you first find out the distinct values. What are the different values that are present in that attribute? And for each distinct value, you then count how many times these distinct values are occurring. Then the value that is occurring the most number of times is the mode. Now, there can be a case when every value in the attribute is unique. That means all the values have a frequency of 1. Therefore, in that case, there is no mode. It is not that all the values will be mode. No, there will be no mode because all the values are occurring the same number of times, and there is no value that appears more or the most number of times as compared to others. Okay, now on the contrary, there can be a case when more than one value is occurring the maximum number of times. So there are, say, an attribute has values 5 and 8 which are occurring 10 times each. So both these values will be the mode if 10 is the highest frequency in that particular attribute. Okay. So multiple modes are possible, they are allowed, but uh, uh, they are only allowed when the frequency, the maximum frequency is more than 1. All right. Now, mode is applicable to both numeric and non-numeric data, because you just have to count the occurrence. You do not have to do any calculation on the data. So even if your data is non-numeric, like it is in the form of strings like grades, say A, B, C, A, B, C. So the grade that is occurring the maximum number of times will be your mode. Okay. Now coming to the last topic of this chapter, it is the modes of variability, the measures of variability. So measures of variability basically tell you how much diversity you have in your data, how much variation you have in your data. So there might be a case when two different types of data sets or two different types of collection of values have the same measures, same values for the measures of central tendency, which are the mean, median, and mode, but their measures of variability might be completely different. Okay, so that is why calculating both measures of central tendency and measures of variability is important. So measures of variability tell you about the variation or diversity in the data that you are considering, and the examples of measures of variability are range and standard deviation. So range is nothing but the difference between the maximum value present in that attribute and the minimum value or the smallest value of that attribute. And again, since it is an arithmetic difference of the values, so it is only applicable for numeric data. Also, it is easily affected by the presence of outliers, because an outlier will be either very small value, generally the smallest value, or the largest value. And since range depends on the largest and smallest value, it's the outcome will be heavily affected if there are outliers present in the data for which we are calculating the range. Okay, so this is again the data that we studied for the heights of students in a class. Now in this particular case, the highest value or the largest height is 115 centimeter and the smallest height is 85 centimeter. So to calculate the range, we will take the difference between both these values, maximum value minus minimum value, which is 115 minus 85, which gives you the range as 30 centimeter. Okay, so this gives you an idea about the data that the heights of the students are at a maximum. The maximum difference between the heights of the students that are considered is 30 centimeters. So there are a range of students which have heights with a difference of 30 centimeter. Okay, so this is telling you how much variation, diversity you have in your data. The last topic for the day is standard deviation. So now standard deviation, unlike range, uses all the values for calculating how much data is spread in your what is the spread of your data. So basically range was utilizing only two values, the maximum and the minimum, whereas standard deviation is using all the values, and it is based on a formula that I'll be just telling you in the next slide. And again, since numeric computation is involved, standard deviation will only hold true for numeric data. You cannot calculate standard deviation for textual data or non-numerical or categorical data, right? Now, small value of standard deviation means that the data that you are considering does not have much variation in its values. Variation means the values are very close by, very similar to each other. They are not lying far apart. So, a data say 10, 11, 12, 10, 11, 12, 10, 11, 12 has a smaller variation as compared to the data 10, 20, 30, 40, because the difference is the difference in the values, how far apart the values in the data are is larger. Okay, So again, the larger the standard deviation means larger variation, larger diversity in data, and this is the formula for calculating standard deviation. So standard deviation is denoted by the Greek letter sigma, and it is given by under root or the square root of sum of the difference between each observation and the mean of the attribute, and the square of the difference between the observation and the mean divided by the total number of observations. So I'll just explain this formula in detail. So here what is happening is that if you have an attribute, say A1, and you have values say 1, 2 and 3, first you will calculate the mean of all these values. Then what you will do, you will calculate the difference between this value and the mean. You will get one value. Then you will calculate the difference between the second attribute value and the mean. You will again get some value, and similarly you will get values which have been calculated by taking the difference between the value of the attribute for each observation and the mean. Now you calculate the square of these differences. After calculating the squares, you add all of them and you divide by the total number of observations, and then you take the square root. So I'll explain this with an example. Say you have to calculate the standard deviation for this particular data, which is the height in centimeters. So these are the original values that are given to you. In the first step, you will find the mean. How do you find the mean? You will take the sum of all these values and divide by the total number of values. So we calculated in the previous slide that the sum divided by n will give you the mean as 101.33. Okay, so the first step is done. Now in the second step, what you will do, you will start taking the difference between this value and the mean. So 90 minus the mean, which is 101.33, will give you minus 11.33. Then you will do 102 minus 101.33. You will get some value, and similarly you will calculate the differences corresponding to each of these observations. So we will subtract the mean from each of these observations and you will get a list of differences, right? These are the list which are in the form of x. X means the observations taken from here minus the mean. Now you have to calculate the square of each of these values. So you have to calculate the square of the differences. Now taking the square of minus 11.33 is 128.37. The square of 0.67 is 0.36. Square of 8.67 will give you 75.17 and so on. Okay. Now once you have calculated all these sum, you will add all these values. Okay, you will add all these individual sum and you will get this particular value, which is the sum of the squares of the differences. Now what you have to do, you have to divide this combined sum, that is 93.8 that you have obtained from here, by the total number of observations. So 93.8 divided by 9 will give you 104.22, and at the last step you have to take the square root, and this will give you the final value for standard deviation. Okay, so this was all for today's video. I hope you have understood this chapter for understanding data. Thank you for watching. Till we meet in the next video, mind your exam.